Hey, hi, I am IT PhD and today we continue our adventures in C language and we will talk about type conversions. It's a quite interesting thing that in C language there is an implicit type conversion. So if we would try and make some new variables like integer a and it will be assigned to it -10, we know that by default integers they are signed, unless we kind of forced it to be unsigned. Yeah, so we can say that integer a equal to value -10. And then we also, let's create unsigned integer this time, and it will be integer like 5. Yeah, we would give it will be b. Yeah, so we would have b, which is equal to value 5, unsigned, so everything is fine. So let's first, I'll show you this thing. Let's first print integer a, but we will print it as not decimal integer, but as first we will print it as unsigned. So let's try to print signed integer negative as unsigned integer. Let's write it here. Signed a will look as unsigned like this. Let's take a look. You see? So our signed integer, if we try to output it as unsigned, it will have very strange look. Why it's so? In my past video I showed you how data types looks like. So basically, for example, integer, it store its information in 32 bits, and if it's signed, it's take all these 32 bits, so it's basically 8 bits and another, so it's like 4 times. So if it's signed, it stores this it's pretty quite straightforward. Just start from the less significant bit toward the most significant. So for example, this is 1, this is 3, and etc. So if it's unsigned, but if it's signed, the last digit will be signed digit. That's why if we have unsigned, if we have signed integer, it will have this bit active. So this bit will be active, and then -10 we would have it like this. So 1, 2, 4, 8. So 8 and 2. So this will be our -10. But if we want to, if we try to represent it as unsigned value, unsigned values, they are stored with this signed bit, it's always 0 there. So they plainly go like this. So as we stored here to our signed integer, we store -10, so we stored this value. So now when we output it with our unsigned specifier, now we see this number plainly. So he do not know that it's signed a bit, and he show us just this thing. Quite logical, because this is maximum value for like 4 billions, which is maximum size for unsigned integer. Okay, now we see it. So I talk about it in my previous video, but we would see some more interesting things now. So let's now take a look at such operation. We would add a new container, something very big, like long. So it will like long even. So it will hold not like 4 billion. So it will hold like huge number. So we would create very huge big number, and we would call it like C. We would call it C, and this C will be equal to A plus B. Yeah, and quite logically that, okay, C it's equal A plus B, so it's A plus B, it will be minus 5. It should be, like, it should be minus 5. But if we would, so let's comment this out for now. But if we would print it, so now printf, we would print like C, let's A plus B equal to, and here we have this LLD specifier, so it will be very long digital. Yeah. And let's go next line. And we would insert it here like this. So let's take a look what we will get. Okay. You see, when we made this operation, A plus B, and we should have like minus 5. Why we have such huge number? Because in C language there is such thing which called implicit type conversion. So when C language, when you put something, some operation, and you take integer, signed integer and unsigned integer, result will be unsigned. It's automatically converted. So there is a kind of, let me show you, such ranks which show you priority of the types. So the biggest priority goes to double and floats. So numbers with some stuff after dot, like floating point numbers. They have biggest priority. So if you, for example, if you would take something like, we would come back to this thing later. Let me just show you some priorities. So if we would take float A 0.5 and integer B 1, and we print A plus B equal, let's make it float 2, yeah. And we make A plus B here. So if you would see, yeah, let's run it. You see it's 1.5. We have 1.5. But if we would make it like force this conversion, there is a way to make this conversion manual, so you could control this thing. So if you want to make this everything convert the result to be not a float number but integer, so yeah, if we would just put it like this, like D here, okay, we would have 0. We will have 0, so let's make it like this, 10. Let's put 10 here. See, it's still 0. Yes, because float, it's still, we have on the exit. So result of this operation is float number, and this float number has its own structure, how it's kind of store numbers, and it store numbers in very special way. That's why we just do not have any result here. Yes, but if we would make like force conversion, to do it, you could just put type in front of the variable. So let's make it like this, int b first. Yeah, int b. So if you try it like this, you see you have dot and half. But it's because we're converting our b, which is already integer. So yeah, why to convert it? But if we would convert float to integer, what we will have? We would have 0, yeah, because let's make output decimal. So we would have 10, because when we convert float number to integer, it's go like diminish to minimal number. So if we would have 1.5, like 2.5, let's take 2.5, then you see we have 12. So it's take this .5 and it's just take it off. So you could control this output, but by default, it's yeah, we need to use it float here. It's convert stuff to this type. So to most priority, to biggest priority. So integers, they converted, result of the integers, they converted to floats. So it's go like this. So it's biggest priority, big priority. And this is small priority. So if it would, in our case, in our first program, let's go back to it. In our first program, we have here int and unsigned int. So int, integer, has smaller priority than unsigned integer. That's why integer become unsigned integer, the result of operation. So here we take signed integer, and when we perform operation with unsigned integer, the result appear as unsigned integer. And we have kinda such a number. How to deal with it? For example, you have such problem. Yeah, there are different ways. So first of all, you could just make proper output. Yeah, so better first what you could do is to make your signed int you make your unsigned integer as a signed, yeah, like this. So signed, you could write it like this, yeah. And if you force your unsigned integer to signed, this value, if you would convert it manually, you will have kind of proper result. You see, it's like one way properly. Actually, you always should do this stuff like this. Another way is to use a bit kind of weird way, but still, let me show it to you. Is to use ABS function, which basically make like absolute number. So it will be like ABC, ABS A. So we would make this number, would remove this sign. So it just make it always plus. So let's run it. Okay, you see it works too. This way it works too. Yeah. So you need always to look into it, and better to do always manual conversion. So do not trust your compiler, because it's not a problem with the compiler, but kind of C language, it's how it is in C language. So this priority ranks. So you should always kind of think about it and make your types manually, assign your types manually, or you could get in trouble. Another way to convert types, it's to add some special suffixes. So for example, if you use like u, it means that this static literal will be unsigned. So for example, let's make it like we wouldn't assign b, but we would try like 5 first, like this. So if we do it like this, we have everything all right. But if we would make u here, you see we have this problem. So yeah, there are some special suffixes for your static literals. So thank you much for watching. I hope this video will help you to understand that type conversion is dangerous in C language, and it's better always to put it manually, different types. Don't forget to subscribe at my channel, and good luck. Hope to see your comments. Bye bye.